TTL Computer 2. Today begins our physical design phase for TTL Computer 2. And the first thing that I really did as part of that process was to start to identify and group our logical design elements into what will be physical, printed circuit boards for our computer. And those are the memory card, the registers card, the memory address registers card, the program counter card, the control unit card, the ALU card, our clock card, and then finally the backplane, which all of these cards would plug into. So the first thing to note is just that it's a lot of cards. I guess we're essentially building a mini computer here with all, a computer built of all discrete logic elements. So I guess it's understandable that our chip count is non-trivial. But the other thing is, this is really my first venture into the design and manufacture of PC boards. So if anything, I'm leaning towards having more cards and less dense cards, just because I believe it's going to make it easier for the PC board design, and that'll be obviously a benefit for the physical design effort. Okay, so besides identifying the cards, the other thing that was important to do was to start to identify, the inputs and the outputs for each of the cards, so we can start to look at and defining the card edge interfaces for our computer. So that's something that's started and is still not completed, but it's looking like we're going to need 64-pin edge connectors for our cards, just because of the number of pins. And anyway, that's the way that's looking now. All right, so besides breaking up everything into physical cards, I also moved around some of our logical design elements. First off, anything that remained of logical design where we had, we were still using gates in our design, those have all been converted over to 7400 series ICs, and we'll see that when we look briefly at some of the designs. I also added input and output buffers to all the cards, and this was also suggested by one of the viewers back when we were designing the control unit. And but what I've done is I've added input buffers, 74 LS245s for any of the control signals coming from the backplane or going to the backplane. Go through 74 245s, and those are the LS variety of the 245 are Schmidt trigger inputs, and that will give us some level of noise cleanup on the bus signals. So that's a key element there. And then again, any of the signals going back to the bus, we want to go through a specific driver again, so that we have good signals in and out of each of the cards. So let's briefly take a look. We'll jump into here. We'll look at the program counter. All right, so first thing that we see here is, if we think back at our other design, we basically had we built up our counters. We started with a 4-bit counter, and then we had an 8-bit counter, and then we combined those to be 16-bit counters. In retrospect, that probably wasn't a good approach for us. If we were just going to stay in the digital design world, it probably would have been good. But we needed to translate this to a physical design with individual chips. So it probably would have been better just to do the design with the individual chips as I have it now. That's probably a little bit of a carryover from my my career I'm trained as a programmer, computer scientist, and as a habit, we tend to do things in small building blocks and then build those elements up. Anyway, it probably wasn't a good choice to do it that way, and we're back to individual logic elements here for our counters. But we see that we have introduced the 245s for all the signals coming from the back plane. And we already had 245s for the signals going, output signals going to the back plane. But that's, you see that, and we'll see that in all the designs. We have our 245s for input and our 245s for output. Right? And we could say, take a look at the memory circuit. All right, so here is our RAM and our ROM circuit. Again, we see a heavy use of the 245s for buffering. Schmidt trigger buffering coming in on the signals from the back plane, and 245s for out and for in, right, from the memory, from the ROM and the RAM. We'll go through 245s now as their output path. I also have updated most every design has been updated since we looked at it last. I have more of a continued heavier use with the tunnels, because I just think that's going to be a lot easier for me to ensure that our physical design, our circuit designs, again, I'm going to intent is to employ tunnels on the circuit designs, and it'll be a lot easier to make sure that everything is correct that way, in favor of having a lot of the bus lines going all over the place with connections. But that's my thinking now, and we'll see if that holds true. All right. The registers, same thing with the registers. Again, the 245s as input buffers. These registers should be sufficient to drive the outputs directly. So we're not going through 245s for the register outputs. All right, and again, heavy use for the tunnels. Okay, let's take a look at our control board. Now, this, so in addition to using the 240, we see the 245s again for our signals coming from the back plane. And now here's the 245s that are employed to output, as was suggested by one of my viewers. And I looked for his comment to let him know I used that in the final design, but I couldn't find his comment. So if you're listening, I didn't forget you. I just couldn't find the comment to reply to. I also moved in the instruction register. I moved the instruction register from the registers card to here. Again, I was trying to eliminate control signals from the registers card, which had quite a lot. And again, this the instruction register is really only used on this card, so it didn't seem like we needed to introduce another, essentially a bus into the to physical design, when we could just move the register. I also pulled in the instruction step counter, or the tick counter, again into the program, into the control card, because that's where it's needed. All right, so our control and our ALU. Now, this is the most densely populated circuit board. We see our 245s again to buffer and clean up the input signals coming from the back plane, and our 245s, driving the back plane, our output signals driving the back plane. Now, this in the center here is is the decode logic. So you can see we have quite a lot of chips here. what I'm going to try and do is I've ordered some GAL chips, programmable logic array chips, and I'm going to try and implement this all in a single chip. I don't know whether I'm going to be able to be successful with that. Those type of chips are kind of out of date, but anyway, I'm going to do my best to kind of replace this whole decode logic with one chip if I can. It may only be these chips that I can simplify into a single chip, but in any event, I have the potential to eliminate, 4 chips here, or maybe all of these with one single programmable array chip. But we'll see how that goes. Anyway, what else here? I pulled in the flags, has been pulled into the ALU printed circuit board as well. But again, it's used here, so it makes sense for it to be here. All right, but that's our most densely populated card. All right, and then our clock circuit. So this has been, again, we have the 245s here. I may add one more 245 for these couple of control signals up here, which I probably will do. And that's it. So this 245 is driving the clock signal, right? The clock signal outputs to the backplane. All right. Okay, and then our final board will be the backplane board, which is really just going to have really all the bus, the bus pull-ups and pull-downs that are needed, a couple of buttons for the run program, and the reset button will be on not too much, nothing really active on the backplane. The power connector, stuff like that will be there. All right, so that's what our physical design is starting to look like. I really need to, go over all of these card level interface points are not finalized. I need to go over that in more detail. So that's it for today. I will be doing another short video for those that want to download the digital simulation project, and I'll just show you what you need to do to get the project up and going, because you're going to have to do a little bit of configuration for wherever you do the installation of that. But that's it for today. Thanks for watching.